Okay, as we roll into this next lesson, you're going to find it looks a lot like what we've been doing the past couple of lessons. We're still going to be working with parallel lines, but the big difference here is the question is going to be, are these lines parallel? So far you've been given, here's some parallel lines, and you've answered a lot of questions about the angles. Now we're going to be telling you information about the angles and asking if that makes the lines parallel. So like you see here, it is the converse. We're going to do the converse of all the theorems and postulates we've done. First is the converse of the corresponding angles postulate. You'll remember a converse takes your hypothesis, your conclusion, and does a flip-flop with them, just switches them around. So let's read through this converse. It says if the lines cut by a transversal form congruent corresponding angles, then the lines are parallel. Let's sketch that out. So according to our hypothesis, we have a couple of lines that are cut by a transversal, maybe something like this. Let's call these lines A and B. And they're cut through by a transversal, and they form congruent corresponding angles. So maybe we see this set of angles here as a match. These are congruent. Then the conclusion is the lines must be parallel. So we would say that our A line has a parallel relationship to the line B. A is parallel to B. And that's how the converse works. It happens to be true, just like the original statement we've been working with. Now, these are the tests for parallel lines. Of course, we can use the converse of the corresponding angles postulate, but we have all these other tests as well. And notice, I'm just going to scroll down here to the bottom, they all have the same conclusion. The lines are going to be parallel. And so these are different ways we can tell if lines are parallel. You don't have to have all of them in any particular problem, but just one will do it. So here we go. If we have if we have two lines, we don't know if they're parallel. If we have two lines and we do a test or we investigate alternate interior angles, maybe like we check this angle out, and alternate interior to that is this one. If those are congruent, then we have parallel lines. The converse of the alternate exterior angles theorem. That would say you're taking a look at a picture and you see two lines, you see a transversal, and maybe this exterior angle here is shown to be congruent to its alternate exterior angle down here. If that's what you've got, then you can conclude that the lines are parallel. The same side interior angles theorem. Kind of the same idea. If you see two lines and you've got a transversal cutting through them, if you check out angles that are on the same side and interior, this angle here and this angle right here. Now these have to be supplementary, so I want to check, do they add to 180? Do they add to 180? And if they do, if the answer there is yes, then the lines are parallel. The same side exterior angles theorem, to finish this off, is the last test. You're taking a look at two lines, you see a transversal, you check out angle on the exterior, maybe angle 1, and you look at angle 2, it's same side exterior, and you add those up. Do you see that if the measure of angle 1 added to the measure of angle 2 is equal to the 180 total? If the answer is yes, then the lines are parallel. So all of those are ways to make this conclusion. The lines are parallel. Any of those tests will work. So you have 5 different ways to tell if lines are parallel. Let's take some practice. Okay, we're going to use only the given information, and we're going to tell which lines are parallel from that given information. So we have lines running this way, A and B. We also have C and D lines, but let's take them one at a time. Okay, our first one is angle 1. I'm going to highlight that, and we're told that angle 1 is congruent to angle 5. So if we take a look at which of the lines is the transversal, the easiest way to do that is to take the vertex here at angle 1 and the vertex here at angle 5. And remember, the transversal is connecting those vertices, so that would make C the transversal line. So C is the transversal line, and it is the transversal for line A and line B. So if any lines are parallel, it'll be line A and line B. And now angle 1 and angle 5, those correspond to each other, and we were told they were congruent. So that would be our corresponding angles postulate, or actually the converse of it. So let me write that. It's the converse, we'll abbreviate that, converse of the corresponding angles postulate. So which lines are parallel? Our answer for this is going to be A is parallel to B. All right, let's clean this up a little bit and let's check out the next one. In our next one we have angle 3. I'm going to highlight that again. So angle 3 right here, and that is listed as congruent to angle 15. So let's find our transversal. One more time, we're just going to take the vertex at angle 3 and connect it with the vertex at angle 15. That's going to be line B is the transversal. So what does line B cross over? Line B crosses over line C and line D as the transversal. So 3 and 15, which kind of angles are those? Those are on alternate sides of our transversal and interior to the red lines. Those are alternate interior. Alternate interior angles need to be congruent. So the converse, we just saw, the converse of the alternate interior angles theorem, that one says that these are going to be parallel lines. Which lines? Well, the lines we highlighted here in red. That's going to be line C parallel to line D. Okay, hopefully you're seeing how this is working. I'm going to find my transversal and figure out which lines it crosses so that I can evaluate whether they're parallel. All right, let's take a look at number 3. We've got a 180 total. Some of our angles need to add to 180 to make parallel lines. Let's see what we have. So angle 6 is mentioned as being supplementary to angle 10. I'm going to follow my same steps as before. I'm going to identify the transversal. Here's the vertex for angle 6. And here's the vertex for angle 10. So connecting those, my transversal is line A. And what does line A cross through? It crosses through line C and line D. Alrighty, so 6 and 10 look like they're on the same side of the transversal and they're interior angles to the red line. So these would be called same side interiors. If you check your theorem, let's just whip it up here. The same side interior angles theorem says that the same side interior angles need to be supplementary. Do they add to 180? We said yes. And so our answer for this is going to be justified with the same side interior angles. Uh-oh, I meant to write converse. Put that in front of it. I'm getting used to what we were doing in the last few lessons. Converse of the same side interior angles theorem tells me that these lines are guaranteed to be parallel, the ones I've highlighted in red, which are C again, parallel to D. All right, last one for this example set. We are taking a look here at angle 1, and angle 1 is congruent to angle 10. Do we have any parallel lines? So first things first, let's figure out what our transversal is. If I take angle 1, I find its vertex here at that point, and angle 10 has a vertex right here. Which line connects them? Hey, do you guys see this? There isn't a line connecting angle 1 to angle 10. So what does that mean? It means that even though they're congruent angles, I do not have a transversal crossing through to form them. So this, since there's no transversal for those angles, then I can't make any conclusions about parallel lines. I've got to say that I don't have any parallel lines because I cannot apply any of the theorems without the transversal. All right, as we go into this next example, number 5, we have to do the same sort of thing. We're going to decide if any of these lines are parallel and justify our answer with one of our theorems or with our postulate. So let's take a look, maybe just pick a couple of angles and let's find a transversal. Let's say we want to consider this 84-degree angle with that vertex right there. And let's come down here to the 101-degree angle with this vertex here. So the way I've got those two paired up, the transversal line is line A. All right, so if I can make a guess about parallel lines, my question on this is really, is the line C and the line D parallel? What can we say about our 84-degree angle and our 101 angle? I'm kind of suspicious about them being supplementary. So if I add 84 and 101, do I get my magic number of 180? Well, pretty clear, pretty quick that that's not 180 degrees. So what does that tell me about line C and D? Line C and D are not parallel. And here's one way you can write that. You could write C, and then using your parallel symbol with D. We know that C is not parallel to D, so we just use a little slash through it. That would be a symbol for not parallel. C is not parallel to D. All right, well, if C and D are not parallel, let's clear this out, then maybe A and B are parallel. So let's check that. Let's take this vertex right here again with our 84-degree angle, and let's come down to line B at this vertex with that 96-degree angle. So that makes this line C, where we're connecting those two, that's our transversal line that we're doing this test with. And so we will be able to test line A with line B. Okay, let's add these up. So our top angle again is 84 degrees, and we want to add that to this 96-degree angle and see if we get our 180 total. So we've got 10, carry 1. Oh, looks like we do. We have 180 total. So that means that line A and line B are definitely parallel. Line A is parallel to line B. And why? We do have to justify this, remember. In fact, let's highlight that because all these are we're going to have to justify. Well, what kind of angles did we just test? This 84-degree angle and this 96-degree angle. What kind were they? Notice that on our transversal, they're same side, and they're lying between line A and B. So these are same side interior angles. Now I'm going to justify with converse of the same side interior angles theorem. You can use those abbreviations. Now in this last example, number 6, we're going to find the value of x. So we're going to do some algebra. That's our question, to find the value of x that will guarantee that A is parallel to B and justify the equation we use. Looking at our picture, A is parallel to T is going to happen with what relationship for these angles that are indicated in the diagram? Oh, look at that. That arrow is pointing to that other angle. I am wrong here. So let me erase this. This angle right here, that 2x minus 10 is right there. See how that arrow is pointing into that interior? So what relationship do we need right here that's going to guarantee these lines are parallel? This is a little bit of a tricky one. Let me use the postulate that lets me give this angle right here. I'm going to use my parallel line postulate that says this 3x angle needs to be a match corresponding to this angle right here. So I'm going to bring that 3x down into this position. 3x here. So I'm going to use, and I'm going to justify that with the corresponding angles postulate. So if these are going to be parallel, that needs to be a 3x. Well, what relationship can I set up between the 3x then and the 2x minus 10? What do they need to add up to? And this is a linear pair here, so they need to add up to 180. So let's write that as our equation. We're going to have 3x plus this second angle of 2x minus 10, and that needs to equal a total of 180 degrees. I hope you see that. Let me show it again with this highlighter. See how this full angle right here is 180. All right, so let's bring in the ninja math. First, let's collect these like terms. Those are making 5x. Bring down that minus 10. Bring down that 180. Let's get rid of that minus 10. Let's wipe it out with the positive 10 ninjas added to both sides. Cross that out. Yeah. We got 5x left, and we've got now a total of 190 here on the other side. So y'all know how to do this next step. We're going to divide to get rid of the 5. Bring that down to just 1x, and take 190 divided by 5. 5 goes into 19. Help me do this math. Make sure I do this right. Come and tell me if I did it wrong, because I'm not good at this arithmetic. 5 into 19. That goes in 3 times. There's 4 left over. So 5 into 40 is 8, I believe. So I think x is 38. And we can justify the equation. Our first part was justifying right here the corresponding angles postulate that let us move that 3x down. And then this equation from where we started, this is our linear pair. So there's my justifying. All right, try these. Really give them a shot so that you can see if you're understanding this. We will definitely check them tomorrow, but see if you can do them on your own.